Yeah, so I'm putting this slide back up for the benefit of those who weren't here earlier, and also to remind us sort of the level and scale of IPv6 deployment that we are talking about. And a clarification, this is the data from the World IPv6 Launch.org website. The IPv6 deployment, it's actually, the numbers in that column are an amalgamation of data from Google, Facebook, Yahoo, and Akamai, showing how much of the network's traffic those content sites are seeing over IPv6. So it isn't a measure of the number of subscribers or the percentage of the network subscribers that are enabled for IPv6, although it reflects the latter. Yeah, and again, the graph of IPv6 traffic as seen by Google as of the 17th of October, it's showing that hockey stick look up and to the right. We're hopeful that this portends good things. So we have a panel session, as I said. We have Axel Clauberg from Deutsche Telekom and Emmanuel Popa from RCS and RDS, who are each going to say a few words. Maybe we can keep it to about 5 minutes each, so we will in fact have time for some interactive discussion about IPv6. Okay. And you are.
It's me.
Yes, you.
Don't be shocked. It won't be a business talk. So, but it's actually raising an interesting question. So it took such a long time to introduce IPv6 services because our business parts didn't really support this move. So they said, well, can I make any incremental revenue with it? Now, we are beyond that point. So IPv6 dual stack services are indeed rolled out in most operator networks now. And also at DT. So within Germany, we have launched dual stack services for our DSL customers who get their voice service produced on IP as well back in 2012. And that's actually the strategy we're pushing forward because we want to retire PSTN in the not too distant future. So currently, we just celebrated that we have 1 million concurrent V6 users in the fixed network. Now, the next big step will be mobile. So we will introduce V6 services dual stack as described previously in our mobile network during next year. Now, it is very difficult for DT actually to publish operational data. So this must be some random snapshot from a random operator, which somehow made it into my slide set, but from a random link. But still, it gives an interesting indication that we are almost at 10% IPv6 traffic, sometimes more, sometimes less these days, which is quite impressive. Now, that sounds like we can lean back, we did the job, V6 is there, and the internet can survive. Well, I think we shouldn't lean back. We have to think actually how networks of the future can be run. And this is very much related to the last presentation. Actually, we have increased complexity for the operators by moving to a dual stack service because we just added one more protocol to the picture. And on the left side, you see a random snapshot of protocols we're running in our networks. And we just added one more, and we're running IPv4, IPv6, yes, and that layer 2.5 protocol in our network MPLS. Question is, which protocols do we actually need moving forward? And I will reuse part of that slide in my keynote tomorrow morning as well. So if you're curious what we're doing, just listen to the keynote tomorrow morning. We believe we can actually simplify our networks drastically. And it's actually interesting if you think about that step, moving from a dual stack to a V6 only world, what the advantage actually is. We will still need to deliver IPv4, definitely. But IPv4 is a service, like many other services as well. If we take away that burden of running IPv4 in the core of our network, we can actually use the full advantage of IPv6. And we can monetize finally IPv6 as well. Now, how to do that? Well, there's a huge address space. And we had that discussion at the IETF meeting in Berlin. We had that discussion at the recent RIPE meeting in Athens last week. There is actually an opportunity to make use of the large address space to build a better internet. And this is finally a differentiator for IPv6, which will allow us to monetize it as well in a much better way. That brought up many discussions, especially in the IETF. Because people said, well, you want to differentiate services using v6 address space. We have invented the diffserv code point, so why don't you use that? Well, for me, the diffserv code point belongs to my customers. So if I touch the diffserv code point, my customers have problems. If I use addresses, I can do it way easier because the addresses belong to us, if I have enough addresses. And yes, we do have enough addresses in v6. Likewise, we can finally use a better structure in the v6 addresses, and we can actually also build a little bit easier security by using the fact that certain address combinations are just not possible or should not be possible. So we can just stop this unwanted traffic using very simple access control lists. Now, we have to do it. We have to prove that this is possible, and that's what we're doing at DT within our terrestrial stream architecture. We're running this successfully in a pilot in Croatia since December last year, and we definitely will extend this moving forward. And we have just agreed also within RIPE that this is a viable way forward to use address space for service differentiation. And I think indeed a big task for us will be for the future to simplify not only the fixed network, which we already did here, but also to simplify mobile to a much larger extent than we've seen in the previous presentation. And that will definitely require a lot of work moving forward. So anyone who wants to join us in this effort, you're definitely welcome. Thanks.
Hello again. My name is Emmanuel Popa, and I'm IP Design and Backbone Manager for RCS and RDS. I will be concentrating in these few slides upon the obstacles that we see in raising even more the adoption rate within our network. So I will briefly skip through the introductory slides. A little bit about our company. We're the only quad-play provider in Romania offering video, broadband, telephony, and mobile. We have the largest market share for video and broadband. We've recently launched the gigabit service in Romania. We use a GPON technology over fiber to the building and fiber to the home infrastructure. We are using a PPP over Ethernet authentication model. We have our own BRASs or BNGs. And CPEs are not mandatory within our network, so we can be flexible and let the customer choose his own CPE. We started the deployment of the IPv6 technology in our network in October 2011 with a beta test, which I can say, excuse me, it was a real success. We had almost 12,000 customers joining in for the beta test program. After 6 months, we decided the beta test was final and the technology is mature enough, and the BRAS servers were doing pretty good, so we decided to do the final deployment. So in June 2012, we were ready for a world IPv6 launch. And since then, all of our residential customers, almost 1.5 million, are able to use IPv4, IPv6 dual stack in our network. So it all depends on the devices that the customer uses. The most interesting slides come up right now. So what I wanted to share with you is the evolution, first of all, the evolution of IPv6 and the operating systems. We are seeing a solid growth ratio in operating systems in terms of usage for our customers. So over the last year, we've been seeing a growth from a little bit over 40% to more than 60%. And I'm talking here about at least Windows version Vista. So Windows 7 and Windows 8 are pretty good, and IPv6 is enabled by default. And also the Mac OS X, also with even if with a different Happy Eyeballs implementation. So operating systems are doing pretty good. We should also see a solid growth ratio in IPv6 adoption rate, considering the growth of the ratio of operating systems supporting IPv6 by default. This was taken from the Net Market Share website. But we really see a problem with the CPEs. A couple of years ago, we started testing a lot of CPE devices, and right now we have a couple of models that we can recommend to our customers, and we can sell them to our customers or provide them for free sometimes. The requirements that we have regarding IPv6 deployment in our network are IPv6 over PPP over Ethernet and DHCP-v6 prefix delegation. We actually allocate a /56 prefix for each residential customer. What we see in the last year, the ratio of customers using home gateways has been growing steadily. And one of the biggest advantages that we had in our network on the initial IPv6 deployment was the high rate of customers using or not using home gateways. That means that the customers connect with directly with their PC or with their laptop to our PPP over Ethernet connection. So they are using the PPP over Ethernet client in the operating system. So that was easy to achieve a high rate of adoption with IPv6. But what you can see on the bottom of that graph, the small thin green line, that is the percentage of CPEs supporting IPv6 right now from the CPEs vendors. So this is the graph with the IPv6 adoption rate evolution in our network. It's taken from the AppNIC Labs measurement site. We can see that in June 2012, when we started the full deployment in the network, we easily grew up from almost 0% to almost 20%. So 1 out of 5 customers would prefer to use IPv6 when connecting to the internet. And then this in the second half of 2012, this has grown to almost 25%. So 1 out of 4 customers preferring IPv6. But since the start of 2013, the adoption rate was very steady, around 25%. So we were asking ourselves, considering that IPv6 deployment is enabled all over the network, and considering that we were expecting a linear and steady growth over the adoption rate in our network, we are seeing this line with the adoption rate not growing anymore. And we think this is due to the fact that some of our residential customers are migrating their PCs, laptops, and mobile devices behind the CPEs, which do not support IPv6 right now, at least not with the requirements that we have. So the final question that is here right now is IPv6 ready home gateways are not ready yet from our point of view. The question is, what are vendors waiting for, and how we can find a solution for this problem in the future. Thank you.
So if you would like to share this link.
Sit closer, then it's easier to share the mic.
Okay, good. Thank you. So what I would like to do now is I have a couple of questions, and then I'm going to ask you two if you have a couple of questions for each other, and should there be any time left over, then we'll see if somebody here has questions. So the first question I would like to ask is, one of the things that came up at the RIPE meeting in Dublin earlier this year was this: some operators were reporting that they were a little surprised by the actual traffic patterns in their networks when they enabled IPv6, that there was more traffic in their network than they had necessarily expected by enabling IPv6. I wonder if either of you have seen that sort of thing happening within your networks, or had other surprises, things that in your network that were different than you expected.
Well, I believe we can second that we were a little bit surprised to see the high IPv6 adoption rate and a fairly high IPv6 traffic volume. But I think that's quite understandable if you look at the large volume traffic slides like what was pointed out earlier, as Google supported IPv6, as Facebook is supporting V6, Yahoo and a couple of others as well, that accelerates, as those are the main traffic sources, also the V6 traffic substantially. So it's quite understandable. It's actually quite interesting if you do a V6 only experiment and try to access the sites you're normally accessing, how much is still working and what's not working. So when we started that work on the new architecture, our lightweight 4/6 was not 100% ready yet, but the lab was ready. So we were all using V6 only, and that was an interesting experience.
So one of the things that we noticed was, and was a surprise for us, was that IPv6 traffic was coming towards us only from the CDN providers, like Google and Akamai and this kind of content providers. We were expecting much more IPv6 traffic from other operators, which we didn't see, and we still don't see in the network. Another interesting thing that we've seen with the IPv6 traffic was, and surprisingly for us, we had more IPv6 traffic within our network than we could see on the Internet Exchange Provider graphs in Europe, which when you talk about IPv4 in DKIX, for example, they have more than 2 terabits per second in the peak hours. But when you talk about IPv6, they only have around 10 gigabits of traffic, which is less than what we have in our own network. And it's only done with Google and Akamai or something like that. And the other thing that I wanted to share was there's something else, but it's slipping my mind right now.
Okay.
So
well,
I will remember.
Maybe it will come back to you, and you can share it then. Then I guess another question. Clearly, both of your organizations took a very planful approach, although that's not a word, planful, to deploying IPv6. Put a lot of thought into what can we do better, or how can we achieve this, instead of having to do it in a hurry. As we run out of IPv4 addresses in the world, and large-scale NATs won't cut it forever, there should be some operators who are trying to do it a little more quickly. Any advice about where not to waste time if you have to deploy IPv6 expeditiously?
Our single advice is do not ask for permission, ask for forgiveness after deploying IPv6.
Good advice.
Well, I heard something interesting also. Customers usually don't notice when you switch on V6. And there was a long discussion also within DT before, can we just enable V6 and what would happen to our customers? And I think indeed things worked as expected and without any issues. And sometimes we have to be a little bit more courageous. Sure, there were lots of issues in that long process until we could finally switch it on. On the vendor side, there were lots of missing features or not expected, not working as expected. But I think we're beyond that stage, so people can be way more aggressive now on their V6 offers than anyone who started with this in the early 2000s.
Great. Thank you. And so do you have any questions for each other, or shall we throw it open to the floor briefly?
Well, I think your remark on the home gateway is quite interesting, and indeed that was one of the areas where we needed to wait as well until we had home gateways rolled out, which would support the dual stack service. Now, I think it's a problem area overall, because we will see the need actually for a lot of innovation in the home network. And if you monitor what's going on in the ITF, I think HomeNet is one of the more complex discussion areas in the ITF. And the problem I see here is that actually the CPE business is a very low margin business for our vendors. So typically you don't have the top engineers designing the CPE software, but you find the software somewhere open source on the internet, you compile it, you give it to the one who's buying the box, and then you go through a couple of cycles until you have a working box. So I think there is a need for also an open source activity, I would say, on a proper innovation-orientated home gateway moving forward. So it will be much easier to have kind of a stamp on, and you know that all the required features are in there. I just wonder how you think about such an approach.
That's right. We've seen a lot of feedback from the open source community on IPv6 working in our network, and we've been supporting them. And they've done a lot of progress with making all that open source software for the CPEs working with IPv6 in our network, and that's great. But the only problem is that this is a very small figure out of all the customers in our network that are trying to upgrade the firmware on their CPEs just to support IPv6, because actually there is no incentive for the end customer to upgrade to dual stack. The end customer is not going to see a better service, is not going to see a cheaper service, is not going to see higher speeds with IPv6. Maybe the customer will see longer delays with IPv6, and he's not going to like that. So yeah, open source is good, but I think we are going to start building a factory of CPEs and start becoming a vendor of CPEs, because this is going to be much easier than convincing all the CPE vendors that all CPEs should support IPv6 as soon as possible. Now all the content providers are ready, all the operators are ready, the backbone networks have been ready for the last 20 years, so everybody's ready, but the devices are not ready. The operating systems are doing a great job from our point of view. And I think the mobile devices also, they are really supporting IPv6, at least on the Wi-Fi interfaces. But the CPE is always going to be in the customer's home. Maybe even multiple CPEs together with the HomeNet standards and everything that IETF is developing right now on this subject. It's not enough from our point of view.
Okay, thank you. Any questions from the audience? Okay.
Yeah, very, very short question. Actually, the title of your presentation was very interesting, very short presentation, but it should be a very, I think, one single presentation for that title. I mean, IPv6 monetization is a very interesting topic. You mentioned something about because of you can monetize the IPv6 because of larger addresses space, much bigger addresses space. But could you be more specific about what you say that you can monetize IPv6 because of the bigger or much bigger addresses space?
You obviously detected that I like provocative presentation titles. But there are a couple of areas where we can actually translate this to money. Money on one side, savings, because obviously a simpler network where you just run IPv6 in the core of your network reduces your OPEX compared to a very complex network you're running. So on one side, it has an OPEX impact. If we look at other monetization opportunities, I think we indeed need to look at the future home. And that's related also to what's happening in this overall Internet of Things, M2M market, whether it's sensors in your home, whether it's e-health services. I believe there's a huge opportunity to finally use the existence of IPv6, and that might accelerate also that people are willing to deploy new home gateways and even buy a $50 new home gateway to support IPv6, that they can finally get this, because many people are investing into home control systems now, and with that you might just get a v6 CPE for free. So I think there are tremendous opportunities, especially around the M2M market. But definitely for us, the main reason to go this route within the terrestrial architecture is to simplify operations.
Okay. So, all right, please.
So I completely agree with this statement. It's just my opinion is right now that at this time you can monetize IPv4 more than IPv6 just because of the IPv4 exhaustion. So imagine a provider that would find a solution to offer the internet access services only on V6, and the provider would sell all the IPv4 space that he holds. He would make a lot of money, right?
All right.
In fact, there was I'm not sure whether it was serious, but it was one of the large US operators who made a statement at RIPE last week that he could actually fund the whole network renovation project just by selling off the V4 address space.
And on that cheery note, I'm afraid we've run out of time, so I'd like to thank the panelists. I'd like to thank all of today's speakers, and thank you all for coming out to today's session on IPv6.